Today we're going to look at using the factor method to solve other types of equations, even though they may not be linear or quadratic. When using the factor method, you basically move all terms to one side of the equation. I normally go to the left using addition or subtraction. Then you will factor the equation completely. Now remember, there are lots of different types of factoring. There's GCF, greatest common factor. There's factor by grouping. There are techniques for factoring trinomials. There's also the difference of two squares. There would be the sum or difference of cubes. So there are lots of different types of factoring. But then, once you have factored, you set each factor equal to 0 and you solve. Now this phenomenon is called the zero product principle, and be sure to check all solutions. Here's an example of a factoring problem. Notice that it's degree 4. That means it has an exponent of 4. If you look closely, there is a greatest common factor. 5 will divide into both the 5 and the 80. Also, both terms over on the left have x squared in common. So I will actually divide out or factor out 5x squared from each term. Now basically factoring is dividing. So it's like you're dividing both of those terms on the left. So 5x to the fourth divided by 5x squared will leave x squared. You just subtract the exponents. Then 80 divided by 5, let's see, 5 will go into 8 once and then into 30, that'd be 16, and then x squared over x squared cancels out. You may also notice that the x squared minus 16 is the difference of perfect squares, so that's x plus 4, x minus 4. Now it's factored completely. So step 1 was done, get the terms on the left. Step 2 was to factor. Step 3 is to take each factor and set it equal to 0. So I have the first factor was the GCF. The second factor was x plus 4. The third and final factor was x minus 4. Since I have 3 factors, I should at least have 3 answers. Now if I divide by 5, x squared equals 0, take the square root of both sides, x equals 0. Then x would equal to negative 4 when I subtract the 4, and x is equal to positive 4 when I add the 4. Now when I check my solutions, 5 times 0 to the fourth minus 80 times 0 squared equals 0. Of course, all of this will be 0, so that does check. Then, when I check the negative 4, 5 times negative 4 to the fourth minus 80 times negative 4 squared, well, negative 4 to the fourth is going to give me 256, and then times 5 is equal to 1280, and then negative 4 squared gives me 16 times that 80 is 1280, and you do see that that is true. And the third answer to check would be 5 to the positive 4 to the fourth minus 80 positive 4 squared. And because we have even exponents, we will end up with the same result as when checking the previous solution. So 1280 minus 1280 equals 0. Yay! All 3 solutions do check. Here's another example of factoring. Notice that my degree is 3 and all of the terms are not on the left. So I take and move over each term. Now I have x to the third plus 3x squared minus 25x and minus 75. This type of polynomial is best factored with the grouping method. The grouping method says to Split the problem down the middle, the polynomial, and work with the GCF of the front, which would be x squared. If I take x squared out of x to the third, that's x, and then plus 3. The GCF in the next two terms of this polynomial would be negative 25. Again, if I divide by negative 25, that would leave x plus 3. Notice now that x plus 3 was the common factor, and I have x squared minus 25. But x squared minus 25 is the difference of two squares, so it factors once again. Now I have three factors, and each one is set equal to 0. If x plus 3 is 0, I subtract, and x equals negative 3. One solution. If x minus 5 equals 0, I add 5, x equals 5. The second solution. And if I have x plus 5 equals 0, I just minus the 5 on both sides, and that would give me negative 5. Those are my three solutions. And yes, they will all check.